All right, question 5 on this math subject GRE practice test. This is the fundamental theorem of calculus question. More specifically, the first part of the fundamental theorem of calculus. I'd be very surprised if you didn't see a question similar to this on your test. I know there was one on my test way back in the day. There was also one on the previous practice test that I made solutions for. I think it was question 32 on that one. It's a topic that you typically learn near the start of a Calc 2 class, and something that the test makers definitely think is important. Informally, what the fundamental theorem of calculus, at least this part of the fundamental theorem of calculus, tells you is that integrals and derivatives kind of sort of cancel out. So when they ask you for the derivative of this function, which is defined in terms of an integral, the derivative and this integral are going to kind of sort of cancel out. In fact, if this were an x right here, they'd cancel out a lot more cleanly. If instead of seeing an x squared here, you just saw an x, then your answer would just be little g of x. A lot of times that's how you see the fundamental theorem of calculus written. When you're taking the derivative of the integral from some constant up to the variable x of this arbitrary function, maybe g of t, what you get for your derivative is just g of x. It's just this function right here written with this variable. Why does that work? Well, I'll show you in a minute. But before I do, I want to make a more general statement that ends up being more useful for standardized testing. And that's if you're taking the derivative from a constant to a function. So I don't know, like u of x maybe, of this arbitrary function g of t, then what you do is slightly different than what you did up here. So wait, what did I do up here again? You wrote the g, the little g, because the derivative and the integral kind of canceled out. But for some reason, you replaced the variable that you saw here, t, with what was written up here, the variable x. We're going to start out doing the exact same thing. We're going to write lowercase g here, and then we're going to replace this variable t with what's written up here, u of x. But then you're not done. There's a hidden chain rule going on in here. I'll show you where that is later. And because of that chain rule, you have to multiply this by the derivative of whatever function you see up here, u prime of x. Note that if that function is just the variable x, then its derivative is just 1, so you don't even need to write it up here. We can make this even more general and allow this to be something other than a constant. Maybe we'll call it the function v of x. In that case, what you do is kind of similar to what we did up here. We're going to write little g again. We're going to replace our t with what we see up here, u of x. Then we're not done. There's a hidden chain rule somehow, which makes us write u prime of x right here. But since this isn't just a constant, we use the evaluation theorem, and we have to subtract and kind of do this thing again, except with the function that you see down here. So little g of, instead of u of x, it would be v of x. But then again, we're not done because there's a hidden chain rule, and we get v prime of x. If you love to memorize, go ahead and memorize this purple version. And just note that if you have a constant in place of one of these spots like we do here, since the derivative of a constant is 0, this entire term would go away. And if you have an x in place of your function, since the derivative of x is just 1, you multiply that by 1, which again, you don't even need to write. If you love memorizing, memorize this. That'll allow you to answer the question. Don't believe me? I'll do it for you right now. Here's h of x. We're asked to find h prime of x. In other words, the derivative of this thing h of x, which is the integral from 0 to x squared of g of t dt. I've never taken calculus in my life. I don't know a damn thing about calculus or the fundamental theorem of calculus, but I got this memorized. I wrote it on the back of my hand or something. I'm not advocating cheating, but somehow you know this. If you have this memorized, you can answer this question. Derivative and the integral kind of sort of cancel out. We leave our little g here, but then we replace the variable t with whatever we see right here, x squared in this case. Oh, but then we're not done because there's a hidden chain rule somehow. So we have to multiply by the derivative of x squared, which is 2x. If you want, you then subtract little g of whatever you see right here, 0, times the derivative of 0. But the derivative of 0 is just 0. So I'm multiplying this by 0, and when I multiply by 0, it all goes away. What I'm saying is you get 2x g of x squared as your answer, which is answer C. Don't know what I'm doing, don't understand it one bit, but at least I can get the answer because I have the fundamental theorem of calculus part 1 memorized. The teacher in me hates solving the problem that way because you don't really have to learn anything. But if you like memorizing, go ahead and do that. If you hate memorizing, well, I got good news for you. There's ways to do this problem that don't involve memorization at all. What they instead involve is the fundamental theorem of calculus part 2, aka the evaluation theorem. This is something, if you've taken Calc 2, you've used it a million times and probably don't even think about it as a theorem. Think about it more as a fact of life. It just says the definite integral from a to b of some function, I don't know, g of x dx, sure, is equal to the antiderivative of this function, so capital G, evaluated at b, minus the antiderivative of this function evaluated at a. If you understand the evaluation theorem, you can take this original function h of x, which is defined to be equal to the integral from 0 to x squared of g of t dt, and you can rewrite it without this integral, right? That's what the evaluation theorem tells you. It says when you have an integral from a to b of some function, all you got to do is figure out the antiderivative of that function, evaluate it at the endpoints, and subtract. So in this case, the antiderivative of little g of t is capital G of t, and I'm going to evaluate that thing from 0 to x squared. That gives me capital G of x squared minus capital G of 0. H of x, this integral, is capital G of x squared minus capital G of 0. The question is not asking me for h of x, it's asking me for h prime of x. In other words, the derivative of h of x. Well, that's easy enough to figure out. H prime of x would be the derivative of capital G of x squared minus capital G of 0. Anytime you're taking the derivative of a sum or difference, you take the derivative of each term individually, so capital G of x squared minus the derivative of capital G of 0. Can I figure those two things out? Yep, absolutely. Let's start with the low-hanging fruit. What's the derivative of capital G of 0? You're like, I don't know. I don't know what capital G is equal to. Doesn't matter. Capital G is some function. We changed all of the variables in that function into the number 0. So capital G of 0 is just some number. It's just a constant. The derivative of any constant is just equal to 0. Okay, that's cool, but what about the derivative of capital G of x squared? Well, this is going to be a chain rule problem. We have this outer function, capital G of x, and this inner function, x squared, being composed together. When you're taking the derivative of a composition like that, you first take the derivative of the outside part. The derivative of capital G is little g. Then you leave the inside part completely alone. You don't mess with this x squared here. Leave it as x squared. But then remember, you're not done. You have to multiply by the derivative of the inside function. The derivative of x squared is 2x. Without any memorization, what I figured out is that h prime of x is 2x g of x squared, which was answer C up here. As a math teacher, I love this. I think this is really cool. Going through this exercise is what really helped me understand the fundamental theorem of calculus part 1. You may or may not like it as much as I do. If this feels a little too theoretical, or you don't like the fact that my function here, g of t, isn't even defined, I got good news for you. When you have problems like this, where we're told that g is a differentiable function on the reals, but we're not explicitly told what g is equal to, what that means is I can choose whatever the hell I want g to be equal to, and I'll still get this same answer, C in this case. So if this all felt really theoretical to you and you wish it was a lot more concrete, all you got to do is pick your favorite function for g. What's your favorite function? I don't know, maybe like x squared, but we already have an x squared in this problem, and that might get confusing. So let's let g of t be equal to, I don't know, I like trig. Let's make it sine of t. But there's nothing special with this choice. You can choose whatever function you want right here. If g of t is equal to sine of t, then the function h of x they give us is the integral from 0 to x squared of sine of t dt. This is something we can evaluate explicitly, right? The antiderivative of sine is what, negative cosine of t? And I want to evaluate that thing from 0 to x squared. Sure, no problem. All I got to do is replace all the t's with x squareds, and then replace all the t's with zeros. I can clean things up a little bit if I want. I got negative cosine of x squared minus a negative, so I'm positive. Cosine of 0 is equal to 1. Remember, we don't want h of x, we want h prime of x. So what we have to do is take the derivative of this guy. Ooh, I'm good with derivatives. I didn't feel comfortable with the derivative over here with capital G's and little g's, but you give me negative cosine of x squared plus 1, I can take derivatives all day long. The negative, I think about it as negative 1 coefficient, so that just sticks around. The derivative of cosine of x squared, I'm first going to take the derivative of the cosine part. The derivative of cosine is negative sine. Now I'm going to leave the x squared completely alone, but then I'm not done. I got to multiply by the derivative of x squared, which is 2x. Finally, the derivative of this plus 1 out here is just a 0. What I'm saying is h prime of x is the negatives cancel out. The plus 0 I don't even need to write. I got 2x sine of x squared. Remember that g of t is sine of t, So sine of x squared is just g of x squared. So I got 2x g of x squared. I got the exact same answer that I've gotten, I don't know, like 3 or 4 times on this huge mess of symbols. If you don't like leaving g as an arbitrary function, pick whatever your favorite function is and you'll still get the right answer. I think that's kind of cool.